All right, so this is the video that's going to take us through our Chapter 5 study guide over functions. So if you look at number 1, it says find the domain and range of the function represented by the graph. So if you recall, the domain of a function are all of your x values or all of your input values. The range is all of your y values or all of your output values. So for number 1, everything is in a graph. So what I like to do is I like to go ahead and list the ordered pairs of these 4 points first, and then I can very easily pick out the domain and the range. So this point right here is the point -2, 3. This second point is -1, 2. The third one right here is 1, 1. And the fourth one is 3, 1. So when I am finding the domain, it's going to be all of your x values. So we have -2, -1, 1, and 3. And then your range values are all of your y values. So 3, 2, 1, and then 1 again. Okay, so there's your domain and your range. Domain are your x values, range are your y values. Okay, for 2 through 4, the table shows the number of pens and notepads that you can buy with $12. So number 2 just simply says to find the domain. The domain are your x values, so 0, 4, and 8. Okay, is the domain discrete or continuous? Now, we're just looking at the domain, so 0, 4, and 8. That represents number of pens, okay? And if you think about it, you can have 0 pens, 4 pens, 8 pens, but you couldn't include every single number in between those values. For instance, a half. You can't buy half of a pen. So this one is going to be discrete. Okay, number 4, find the equation in function form for this situation. So we need to write an equation for this table. Now, before you can write an equation, you have to have a slope. Okay, so if you remember to find the slope, you do your change in your y's over your change in x's. So I'm just going to use these first 2 set of points right here. So my y's would be 4 minus 2. My x's would then be 0 minus 4. And you get 2 over -4, which simplifies to -1/2. So I know my slope is -1/2. Okay, so I'll start out with f of x, and remember that's just your y, equals -1/2 x, and then I need a y-intercept. Well, if I look at my table here, this point right here, when x is 0, y is 4, that means your y-intercept is 4. So for our equation, we just tack on a +4, and that's your equation in function form. Okay, moving on to number 5, complete the input-output table. And they give us the function or the equation right there. It says y equals -1.2x plus 4. So to complete the table, all we have to do is take each one of these x values and plug them in where x is in the equation. So first I'm going to plug in -1. So I have -1.2 times -1 plus 4. Well, -1.2 times -1 is a positive 1.2, plus 4 is going to be 5.2. Okay, plug in 0. -1.2 times 0 is just 0, plus 4 is 4. Then I have -1.2 times 1 plus 4. So -1.2 times 1 is -1.2. And then when you add 4, this is really just like taking 4 minus 1.2, and you get, I don't think I'm going to be able to fit it in that box, so I'll just come down here. You're going to get 2.8. That goes in that box right there. And then plug in 2. We have -1.2 times 2 plus 4. So we have negative 2.4. And when you add 4, again, it's like taking 4 minus 2.4. You get 1.6. And there's our table, all filled in. All we did was plug in each of these x values into the equation. All right, number 6. You're putting wheels on skateboards. The function y equals 4x represents the number y of wheels. So y is the number of wheels that are needed for x skateboards. Is the number 15 in the domain? And explain. So remember, the domain is your x value. And in this instance, they tell you right here that x is the number of skateboards. So can you have 15 skateboards? Yes, so you could include 15 in the domain because you can have 15 skateboards. Now, if that were flipped around and that was like the x was the number of wheels, no, you can't have 15 wheels on a skateboard. And I know some of you are going to say, well, yeah, you can. Technically, you know there are only 4. So, but in this case, you can have 15 skateboards. All right, number 7. The perimeter of a square is a function of the length of a side. Write a function for this perimeter. So what they mean right here is just write an equation. How do you find the perimeter of a square? So here's your square. They tell you all of the sides are s. So to find the perimeter, you just add all of those together. So perimeter equals s plus s plus s plus s, or that would just be 4s. Now, is it linear or nonlinear? This one will be linear because there is no exponent with the s. Okay, and we kind of talked about that part a little bit in class. All right. You also want to look at if that s were the denominator of a fraction, it would be nonlinear. So we could also add on to this. There's no exponent with the s, and it's not the denominator. We'll get a little bit more into that here in just a minute. Denominator, remember, is the bottom of your fraction. Okay. All right. So for 8 and 9, it says use the graph or the table to write a linear function that relates x or y to x. So basically, you just need to write an equation for it. So for number 8, remember, for any equation you write, you have to have a slope and a y-intercept. So I know right now I can pick out that this one has a y-intercept of 1. It's right there between 0 and 2. And I need to figure out my slope. So on a graph, rise over run. Now, notice your graph goes by 2's. So my point right here is actually at 1. And when I go up, there's 1, 2. I actually went up 2. And then I'm running 1, 2. So notice your x and y go by different increments. So 2 over 2 is 1. So your slope is going to be 1. So whenever we write our equation, y equals mx plus b, we have y equals 1x, but you don't need the 1 there, plus 1. Slope is 1, y-intercept is 1. Okay, now on a graph, it's a little bit different. Okay, I'm sorry, in a table. All right, because you can't do rise over run for your slope, and you can't just pick out by looking at the graph what your y-intercept is. But I do notice I want to point out this point right here, the point 0, 0. That's going to be your y-intercept because it would cross that y-axis right there at the origin at point 0. So the only thing we need to figure out for this one is your slope. So we did this earlier. Change in y's over change in x's. So I'm going to use, again, these first two right here. So for the y's, I have 6 minus 6. I'm sorry, that should be 6 minus 3. You can't erase just that, so I'll put in a different color. okay? But then for your x's, it's going to be negative 12 minus a negative 6. So watch out for that. So 6 minus 3 is 3, and negative 12 minus a negative 6 actually becomes negative 12 plus 6, which is negative 6, and that simplifies down to negative 1/2. So we put it into slope-intercept form, y equals mx plus b, and we have y equals m, our slope was negative 1/2, x, and then my y-intercept is 0, so I don't need to do anything with that part. If you put a plus 0 or a minus 0 on the end, that's fine, but you don't have to have it there. All right, number 10. It says the function y equals 18 minus 2x represents the number of eggs, which is y, left in a carton after cooking x omelets. So A says graph the function using a domain of 0, 1, 2, 3, and 4. So that means our x values will be 0, 1, 2, 3, and 4. Okay, so before we graph, let's label our axes here. Our x-axis down here, it told us x was the number of omelets, so I'll label that omelets. And then y was the number of eggs that were left, so I'll write that up there. And then I need to figure out what points I need to graph. So each of these numbers in our domain are going to be plugged in for x. So I have 18 minus 2x. Well, the first x value was 0. So 18 minus 0 is 18. So when x was 0, y was 18. Okay, now I'm going to plug in 1. 18 minus 2 times 1. So 18 minus 2 is 16. Now I'm going to plug in 2. 18 minus 2 times 2. So 18 minus 4 is 14. So over 2 up 14. Plug in 3. 18 minus 2 times 3. So 18 minus 6 is 12. And then lastly, plug in 4. So 18 minus 8 is 10. So there's my graph. I covered all the domains they wanted me to use, all the x values. So part B says, is the domain discrete or continuous? We're only looking at the domain, my x values, number of omelets. Okay? You can make 0 omelets, 1 omelet, 2, 3, 4 omelets, and so on. We could keep going. The question is, could you make any in between? Okay? Could I make 1.5 omelets? Yes, I could. I would just only use 1 egg for that. So this one is going to be continuous. Okay?